nature whispers you to sleep. Take time to find a comfortable position as you let the outside world fade away. Let it recede as you bring your attention to the present moment. Settle in, relax, and let's begin. Let your eyes close for a moment, and let the ordinary weight of the day slip away from your shoulders. Picture the surface of a calm, warm sea, just as the last color is draining out of the sky above it. The water has turned a deep, soft blue-gray, smooth except for the slow, rolling swell that never quite stops moving. Somewhere beneath that gentle swell, unhurried, a shape is gliding forward through the dark water, front flippers sweeping in long, graceful strokes, exactly the way they have for longer than almost any other creature alive today. This is a green sea turtle, and we're going to spend the next 2 hours together in her quiet, patient company, and in the company of her many relatives scattered across oceans, rivers, deserts, and forests around the world. Not to study them from a clinical distance, but simply to drift alongside them for a while, as one long, easy night settles in. There is nowhere urgent for either of us to be. Let your breathing slow to match the rhythm of that swell. Let your thoughts settle the way silt settles on a quiet seafloor. Turtles, in one form or another, have been part of this planet for an extraordinarily long time. The very first turtles appeared more than 200 million years ago, making them older than snakes, older than lizards, and old enough to have shared the earth with the very first dinosaurs, long before those dinosaurs themselves vanished. While almost everything else alive back then has changed beyond recognition, or disappeared completely, the turtle's basic design, a body tucked safely inside a protective shell, has proven so effective that it has barely needed to change at all. Think about what that really means, set against the scale of everything else that has happened on this planet since. Entire mountain ranges we now consider ancient and permanent hadn't yet risen out of the earth when the first turtles appeared. The very shape of the continents themselves was still drifting into arrangements barely recognizable compared to today's map. And through all of that immense, slow reshaping of the world, one basic body plan, a reptile carrying its own reinforced home directly on its back, simply kept working, generation after generation, largely undisturbed by whatever else happened to be changing around it. Today, that ancient design lives on in roughly 360 separate species, spread across nearly every warm and temperate corner of the globe, from the open ocean to slow-moving rivers, from parched desert scrubland to damp forest floors. Few animal groups have managed to hold onto a single successful blueprint for quite so long, across quite so many different worlds. Before we follow this particular turtle any further into the darkening water, it might help to hold a clear picture of her in mind, the way you might picture an old friend's face before telling a story about them. A broad, streamlined shell, olive brown mottled with darker patches, smooth along its edges rather than serrated the way some of her relatives' shells are. Long, powerful front flippers, each one doing the work that 4 separate legs might otherwise handle on land. A small, blunt head, eyes dark and calm, entirely unbothered by the deepening night settling in around her. Watch this turtle move now, and notice something that might not be immediately obvious. Her shell is not something she wears, the way a hermit crab wears a borrowed shell it can abandon and replace. It is her. The shell is fused directly to her spine and to her ribs, built from around 50 or 60 individual bones knit together into one solid, protective dome, covered over in broad plates called scuts, made of the very same tough material as our own fingernails. She could no more leave that shell behind than you could leave behind your own rib cage. There's a common misunderstanding worth clearing up gently here, since it changes how you might picture everything that follows tonight. Because her ribs themselves form part of the shell structure, spread wide and flattened rather than curved narrowly around her chest the way ours are, she cannot simply crawl out of an old shell and grow a larger one the way a hermit crab or a snail might. Instead, the shell she was born with simply grows steadily along with the rest of her body, new material added gradually at the edges of each scute, layer upon layer, for as long as she continues to live. Look closer still, toward the front of her face, and you'll notice she has no teeth at all. None of her relatives do, in fact, anywhere in the world. Instead, the edges of her mouth have hardened into a sharp, precise beak, not unlike a bird's, perfectly capable of shearing through tough sea grass or, for some of her relatives, cracking directly through a hard shell. Unlike some of her freshwater cousins, who can withdraw completely into their shells at the first sign of danger, this turtle cannot pull her head or flippers in at all. Her whole body has been reshaped instead for speed and efficiency through open water, flattened and streamlined, flippers long and paddle-like rather than the short, clawed legs a land tortoise might use to shuffle across dry ground. What she has traded away in defensive retreat, she has gained back many times over in the sheer, effortless grace of her swimming. And right now, gliding along beneath that darkening sky, she is doing something else remarkable, something her body allows without any particular effort. She is resting, holding her breath, in a way few other animals could manage. Certain sea turtles, tucked into a quiet ledge or wedged gently beneath a rocky overhang, can remain submerged for 4, 5, sometimes as long as 7 hours at a stretch during a deep, unhurried rest, their heart rate slowing dramatically to stretch every last useful moment out of a single breath. That kind of extended rest depends on a heart rate slowing down to a degree that would be genuinely alarming in almost any other animal, sometimes dropping to just a handful of beats per minute during the deepest, most restful dives. Combined with a bloodstream specially adapted to tolerate a considerable buildup of carbon dioxide without distress, this allows her body to stretch a single lungful of air across hours rather than minutes, an ability shaped by countless generations of ancestors who found it far safer to rest quietly underwater than to surface repeatedly where predators might be watching. Let your own breathing slow a little further now too. In, gently, and out, just as gently, in your own unhurried time. Somewhere behind her closed, dark eyes, an entirely separate sense is quietly at work, one so remarkable it still isn't fully understood even by the scientists who've spent careers studying it. This turtle carries what researchers call a kind of magnetic memory, an ability to sense tiny variations in the Earth's own magnetic field, and to use that invisible information the way we might use a map, to navigate across entire ocean basins with an accuracy that still seems almost impossible for an animal with no instruments, no charts, nothing beyond its own quiet, ancient sense of place. Researchers have run careful experiments over the years attempting to understand exactly how detailed this magnetic sense really is, and the results keep suggesting something more precise than a simple compass reading. Different regions of open ocean carry subtly different magnetic signatures, shaped by the shifting rock beneath the seafloor, and it now appears a turtle may be able to distinguish between them closely enough to recognize, in effect, an entire magnetic address unique to her home beach, imprinted sometime during her very first vulnerable swim away from the nest, and carried faithfully with her for the rest of her long life. Decades from now, whenever the time finally comes for her to lay her own eggs, she will use that same sense to return, with startling precision, to the very same stretch of beach where she herself hatched many years before. Sometimes navigating home across thousands of kilometers of open, featureless ocean to find one single, unremarkable strip of sand again. For now, though, there is no beach waiting. There is only the dark, gentle water, and the long, easy rhythm of flippers moving her steadily forward into the night. Let the turtle continue her slow journey through open water for now, and let your mind drift instead toward a quieter stretch of shoreline, somewhere else along this same warm coastline, where the sand itself is holding a secret. Buried beneath that sand, in a chamber dug carefully some weeks earlier by another female just like her, a clutch of round, leathery eggs has been resting patiently in the dark, warmed slowly by the sun filtering down through the layers of sand above them. Here is something worth sitting with for a moment. Unlike almost every mammal you've ever known, the sex of each hatchling inside those eggs was never decided at the moment of conception. It's decided instead by something far simpler, and in its own way far stranger: the temperature of the sand surrounding each individual egg as it develops. Warmer sand, closer to the surface, tends to produce more females. Cooler sand, deeper in the nest, tends to produce more males. An entire future generation, shaped quietly, egg by egg, by nothing more than the gentle warmth of the sun overhead. This same delicate mechanism has, in recent years, become a source of genuine concern among researchers tracking the effects of a gradually warming climate. As average sand temperatures on many nesting beaches continue to climb, some populations have begun producing overwhelmingly female hatchlings, year after year, a shift subtle enough to go unnoticed for a long while, but significant enough, over enough seasons, to eventually affect how many breeding pairs a population can sustain going forward. It's a quiet, almost invisible consequence of a changing climate, playing out grain by grain of sand, nest by nest, along beaches that have otherwise looked exactly the same for centuries. Soon, in the deep quiet of night, when the sand above them has finally cooled enough and the beach above lies mostly empty of movement, the hatchlings inside that nest will begin to stir together, as if some shared signal has passed silently between them. Tiny flippers will start pushing at the ceiling of their sandy chamber, each hatchling working alongside dozens of siblings, the whole group slowly, collectively digging its way upward toward the surface, a task that would be nearly impossible for any single hatchling working entirely alone. Researchers who have carefully studied this process describe it almost like a slow, patient elevator ride shared by the entire group. As the hatchlings near the top of the nest dig upward and loosen sand above them, that same loosened sand trickles down and settles beneath the hatchlings still lower in the chamber, gradually raising the whole group's position within the nest, all of them rising together, layer by layer, until the very top of the sand finally gives way and the entire clutch spills out into open night air within moments of one another. When they finally break through into open night air, an entire fragile, urgent journey begins at once. Guided by the pale light reflecting off open water, and away from the darker silhouette of dunes and vegetation behind them, dozens of hatchlings scramble together across open sand toward the sea, moving as quickly as their small flippers can carry them, racing against gulls, crabs, and the simple, unforgiving math of how few of them will actually survive to reach the water at all. Once they finally reach the surf, the journey only intensifies. For the next full day, sometimes closer to 2, each hatchling will swim almost without pause, a period researchers call the swimming frenzy, driving itself steadily out past the shallows and the rocks and the countless waiting predators of the shoreline, toward the relative safety of open ocean currents, often marked by drifting rafts of floating sargassum weed, where a young turtle can finally rest, feed, and begin the slow work of simply growing older. That swimming frenzy asks an enormous amount of a creature only hours old, powered entirely by a small store of yolk still carried inside its own body, absorbed gradually during those final days before hatching specifically to fuel this one exhausting, non-negotiable effort. There is no pause built into this stage of a hatchling's life, no safe harbor along the way, simply a single, continuous push outward until the relative safety of open water and drifting cover finally arrives. Some of these same hatchlings, particularly among the loggerhead turtles found in the Pacific, will go on to complete a migration almost too large to properly picture. Turtles hatched on the beaches of Japan have been tracked, using tags and satellite data, crossing the entire width of the Pacific Ocean to feeding grounds off the coast of California, only to return again years later, guided by that same quiet magnetic sense, to nest on the very same Japanese beaches where their own journey first began. Picture the sheer scale of that undertaking for a moment. A hatchling small enough to rest comfortably in the palm of one hand sets out across an ocean spanning roughly 8,000 kilometers from shore to shore, with no guide, no map, no older turtle showing the way, relying entirely on instincts and senses built into her before she ever broke free of her own egg. That she manages it at all, let alone manages to return home again years later with such precision, remains one of the more quietly astonishing feats in the entire animal kingdom. Should a hatchling survive that long, difficult road to adulthood, and manage to avoid the many hazards along the way, it may go on to live a truly extraordinary length of time. Many sea turtles are believed to live past 50 years in the wild, and some researchers suspect certain individuals may live past a full century, their exact age difficult to pin down precisely, since the old method of counting growth rings within the bones of a turtle's shell, much like counting rings in a tree trunk, has turned out to be far less reliable an indicator of true age than scientists once assumed. Beneath all of this, quietly, a turtle's senses continue working in ways easy to overlook. Its sense of smell, both underwater and in open air, is remarkably sharp, useful for locating food, and very likely useful too in helping guide a nesting female back toward the particular stretch of coastline she's searching for. And in colder climates, certain freshwater relatives of this same ocean-going turtle have developed an entirely different, almost startling trick for surviving winter. Some species are able to essentially breathe through specialized tissue near the base of their tail while submerged beneath frozen ice, drawing what little oxygen they need directly from the surrounding water, resting almost motionless for months at a time until the ice above them finally begins to thaw. We'll spend more time with those same freshwater cousins a little later tonight, resting in quieter rivers and ponds far from any ocean at all, each one carrying its own particular version of the patience we're already beginning to notice in this one green turtle gliding steadily forward through darkening water. Time has passed since we first found our green turtle gliding through darkening water, and somewhere along the shore behind her, an entirely new generation is only just beginning its own long, uncertain journey into the same wide ocean she has called home for so many quiet decades already. Let's stay with all of it a little longer, and see where the night carries each of them next. Let the shallow water near the beach fall behind us now, and let the ocean itself grow wider, deeper, and darker, the way it does the further you travel from any coastline at all. Out here, far from land, in water so deep that sunlight barely reaches the upper layers before fading entirely into black, another kind of turtle moves through the world, one built on an almost entirely different plan from the green turtle we followed a little while ago. The transition from shallow coastal water to this open, deep-sea world happens gradually, the way any true change of scenery does. Warmer surface currents give way slowly to colder, darker layers beneath, the last visible light fading from blue to a deep, bruised purple and finally to true black, a boundary with no clear line but felt all the same, the way a room grows quietly colder the further you walk from its only window. This is a leatherback, the largest turtle alive today, a fully grown adult capable of weighing as much as 900 kilograms, roughly the weight of a small car. And where nearly every other turtle on Earth carries a hard, bony shell, the leatherback carries something altogether stranger. Beneath a thick, rubbery skin, its shell has been reduced instead to a mosaic of small, interlocking bony plates, embedded loosely enough to flex slightly with the animal's movement, ridged along the back into 7 long, streamlined keels running from shoulder to tail. It is the only living member of an entire ancient family, its own lineage having quietly split away from every other sea turtle well over 100 million years ago. That long separation from every other turtle family alive today makes the leatherback something of a living relic, a survivor from an entire branch of the turtle family tree that has otherwise vanished completely. Every other sea turtle we'll meet tonight belongs to one shared family, descended from a common ancestor considerably more recently than the leatherback's own lineage split away. In a very real sense, watching a leatherback move through open water is a little like glimpsing an evolutionary experiment that succeeded so completely, so early, that it simply never needed to change its fundamental approach again. That unusual, flexible body allows the leatherback to do something no other reptile on this planet can safely manage. It can dive to depths of well over 1,000 meters, deeper, in fact, than most whales ever travel, descending into a cold, crushing darkness where the pressure alone would seriously injure most other air-breathing animals. Part of what makes such depths survivable at all lies in that same flexible, non-rigid shell we noticed a moment ago. A hard, fixed shell, like the one carried by nearly every other turtle we'll meet tonight, would resist compression at those depths in ways that could cause serious internal injury. The leatherback's flexible, cartilage-supported shell instead allows its whole body to compress very slightly under pressure, flexing rather than fighting against forces that would otherwise be dangerous, then returning to its normal shape again on the long, unhurried swim back up toward the surface. And once it arrives at those depths, it does something else remarkable. Unlike almost every other reptile, which relies entirely on the surrounding environment to regulate its body temperature, the leatherback can actually hold its own core body temperature significantly warmer than the freezing water around it, a rare trait among reptiles sometimes called gigantothermy, made possible simply by its enormous size and a thick layer of insulating fat working together to trap heat generated by its own powerful, constantly moving muscles. Scientists have long puzzled over exactly how a cold-blooded reptile manages this feat at all, and the leatherback's own enormous size turns out to be central to the answer. A larger body simply loses heat more slowly than a smaller one, purely as a matter of surface area relative to volume, and when that natural advantage is combined with a thick layer of fat and constant, powerful swimming that generates its own steady warmth, the result is an animal that can comfortably tolerate the near-freezing waters of the North Atlantic just as readily as the warm tropical seas where it nests. A range of tolerance that would be entirely impossible for any of its smaller sea turtle relatives. All of that extraordinary machinery exists, in the end, to support an oddly simple, almost delicate diet. The leatherback feeds almost exclusively on jellyfish, consuming enormous quantities of them, sometimes equivalent to its own body weight in a single day, drifting through open water wherever jellyfish blooms happen to gather. It's a diet most other large animals would consider hardly worth the effort, and yet it has sustained the very largest turtle on the planet for tens of millions of years. Inside its mouth and down along its throat, the leatherback carries one further adaptation perfectly suited to this soft, slippery diet, backward-pointing spines called esophageal papillae, lining the throat almost like the inside of a thorny sleeve. Once a jellyfish is caught, those spines help prevent it from simply sliding back out again before it can be properly swallowed, a simple but effective solution to the particular challenge of eating something with almost no solid structure to grip onto at all. That same simple diet, tragically, has also become the leatherback's greatest modern vulnerability. Drifting plastic bags, suspended loosely in open water, bear an unfortunate resemblance to the jellyfish this turtle has evolved to recognize by shape and movement alone, and all too often, a leatherback mistakes one for the other, with consequences that conservationists across the world have spent decades now working to prevent. Few animals anywhere travel as widely as this one does either. Leatherbacks have been tracked crossing entire ocean basins, from nesting beaches in the tropics all the way to cold, food-rich waters far to the north or south, following the jellyfish blooms wherever the season happens to carry them, making the leatherback one of the most widely ranging vertebrate animals alive on Earth today. Rest here a while, far out over that deep, dark water, and picture it. A single ancient shape, its strange, ridged body cutting steadily downward into the cold and the dark, entirely at ease in a world that would overwhelm almost anything else alive. Let the deep water fall away behind us now, and let the ocean grow warmer, brighter, and considerably more crowded, as we drift in over a shallow coral reef, alive with color even in this soft, fading light. Here, weaving unhurried between towering fingers of coral, we meet another sea turtle entirely, easily recognized by the sharp, narrow, almost bird-like taper of its beak. This is the hawksbill, named centuries ago for that same distinctive profile, and remarkably well suited to a very particular, very specialized diet. Where most animals would find sea sponges too toxic, too sharp, or simply too unappetizing to bother with, the hawksbill feeds on them constantly, its narrow beak perfectly designed to reach into tight crevices between coral heads where sponges tend to grow. Remarkably, many of the sponge species the hawksbill favors most contain compounds toxic enough to seriously harm most other animals that might attempt to eat them, chemical defenses those sponges evolved specifically to discourage exactly this kind of predation. The hawksbill appears to have developed its own tolerance to at least some of these toxins over evolutionary time, allowing it to feed steadily on a food source almost entirely unavailable to any other reef creature. One more example of this same family's quiet talent for finding a viable, specialized niche wherever competition happens to be lowest. For centuries, this same turtle's beautifully patterned shell made it a target of intense human demand, its guts traded internationally as tortoiseshell material, carved into combs, jewelry, and ornamental inlays long before modern conservation law finally recognized just how severely that trade had reduced hawksbill populations across the world. Today, that same historic beauty stands instead as one of the clearest warning signs of how quickly a slow-growing, long-lived species can be pushed toward the edge, when demand for its shell outpaces its own ability to recover. Not far from this same reef, in slightly cooler, more open coastal water, a very different sea turtle patrols the shallows, its head noticeably larger and more block-shaped than any of its relatives, packed with unusually powerful jaw muscles built for a very particular purpose. This is the loggerhead, named for that same oversized head, perfectly adapted for crushing directly through the hard shells of conchs, whelks, and other armored prey that would defeat a more delicately built mouth entirely. Loggerheads carry something else remarkable too, quite literally along for the ride. Their broad, rough-textured shells often host an entire miniature ecosystem of their own: barnacles, small crabs, algae, and various other hitchhiking organisms, so extensive in some cases that researchers have documented well over 100 different species living on the shell of a single loggerhead turtle at once. In a very real sense, a single loggerhead can function as a slow-moving island, carrying its own small, floating community wherever it happens to travel. Some of those hitchhiking barnacles have, over evolutionary time, become so specialized to life on a turtle's shell that they exist nowhere else in the world, found on no other surface, living or otherwise, apart from the shells of sea turtles themselves. It's a small, easily overlooked reminder that even a single loggerhead, moving quietly through the ocean on its own private journey, can end up supporting an entire community of smaller lives entirely dependent on the particular shape and texture of its own weathered, well-traveled shell. Further along the coast, on one particular beach in Mexico, and in scattered locations across a handful of other tropical coastlines, an entirely different nesting strategy plays out. Kemp's Ridley turtles, the smallest and most endangered of all sea turtle species, gather together in enormous synchronized groups called arribadas, sometimes numbering in the thousands, all coming ashore within the very same few days to nest simultaneously, an overwhelming display clearly designed to protect at least some portion of the resulting eggs simply through sheer, overwhelming numbers. Their close relative, the olive ridley, performs much the same remarkable spectacle on beaches scattered across several other countries, and remains, despite ongoing conservation concerns, the most numerous sea turtle species left in the world today. An arribada, when it happens, is genuinely one of the more extraordinary sights available anywhere in the natural world. An entire beach that was empty at sunset transformed by morning into a shifting carpet of turtles, thousands of them digging, laying, and covering nests within sight of one another. An event so concentrated that early naturalists sometimes struggled to describe it convincingly to anyone who hadn't witnessed it firsthand. Scientists still don't fully understand exactly what triggers a particular night to become an arribada night rather than an ordinary one, though offshore wind patterns, moon phase, and some shared internal cue among the turtles themselves are all suspected to play some quiet part in the timing. And in the warm, shallow waters surrounding northern Australia alone, one final sea turtle species rounds out the family, the flatback, found nowhere else on Earth, distinguished by an unusually smooth, upturned edge along its shell, a small but telling reminder that even within this one closely related family of ocean travelers, evolution has continued quietly experimenting, generation after generation, with just how many different ways a turtle might be built. Unlike most of its wider-ranging relatives, the flatback tends to stay relatively close to the continental shelf waters surrounding Australia throughout its entire life, rarely undertaking the vast, ocean-spanning migrations that carry loggerheads and leatherbacks across entire ocean basins. Its eggs, too, are noticeably larger than those of other sea turtles its own size, hatching into correspondingly larger hatchlings that may face slightly better odds during that first perilous scramble to the sea, One more small variation on the same basic theme every sea turtle species tonight has quietly worked out in its own particular way. Let the ocean recede now, the sound of surf fading gradually into something quieter, a gentle lapping of water against reeds and half-submerged logs, as we drift instead into a slow-moving freshwater river, winding through forest and open meadow far from any coastline at all. The whole character of the world changes with this shift, the salt-heavy air of the coast giving way to something greener and more sheltered, the wide, open horizon of the ocean replaced by close, overhanging branches and the soft, constant murmur of moving fresh water. Somewhere nearby, a frog calls once into the gathering dusk, and falls quiet again, leaving only the water's own steady, unhurried sound. Here, resting on a fallen log warmed by the last of the day's sun, a painted turtle sits motionless, her shell patterned in bands of red, yellow, and olive green, among the most widespread native turtles anywhere across North America. Come winter, when this same river finally freezes over above her, she'll do something few animals could survive at all. Tucked into the mud at the bottom, she can allow parts of her own body to partially freeze, her cells protected by natural antifreeze compounds, glycerol and glucose, that keep the delicate machinery of life from being damaged even as ice begins forming around it. When spring finally arrives and the ice above her melts away, she simply thaws, and continues on largely unaffected by months spent suspended in near-total stillness. Researchers studying this remarkable ability have found that young painted turtles, in particular, can survive being cooled to temperatures that would be lethal to almost any other vertebrate animal, their tiny bodies essentially placed on pause for an entire season, metabolism slowed to an almost imperceptible crawl, waiting patiently beneath the frozen surface for warmth to eventually return. It's a strategy so effective that some hatchlings, remarkably, spend their very first winter of life still buried in the nest where they were born, tolerating freezing conditions within days of hatching, before ever making their first journey to open water at all. That same still, cold water hides another quiet trick many freshwater turtles rely on through the colder months. Rather than surfacing to breathe, some species draw oxygen directly through specialized, richly blood-vesseled tissue near the tail, a kind of underwater breathing that lets them remain fully submerged, resting almost motionless, for months at a stretch, waiting patiently for warmer water to return. Not far downstream, in a shallow, sunlit pool, several red-eared sliders bask together along a half-submerged branch, easily recognized by the small, bright red patch behind each eye. Native originally to the Mississippi River Basin, this same adaptable species has since been introduced, largely through the pet trade, to slow-moving waterways across much of the world, thriving so successfully in some new environments that it has become one of the most widespread reptiles on the entire planet, for better and for worse depending on what it happens to be competing with locally. That same adaptability, so admirable in its native range, has made the red-eared slider something of a cautionary tale elsewhere, outcompeting native turtle species for basking spots and food in rivers and ponds far from home, a reminder that even a genuinely successful, resilient species can create real difficulties once it's moved somewhere its own natural checks and balances no longer apply. Beneath the surface nearby, hidden almost entirely within the silt at the bottom, something considerably less delicate waits in perfect stillness. This is a common snapping turtle, armed with a powerful, hooked beak and a neck capable of striking forward with startling speed and force. Its close relative, the alligator snapping turtle, found further south, has developed an even stranger, more specialized hunting trick. Resting motionless with its mouth held open, it wiggles a small, pink, worm-shaped growth on the floor of its own tongue, luring curious fish close enough to strike, an ambush so effective it requires almost no active pursuit at all. The alligator snapping turtle also happens to be among the largest freshwater turtles anywhere in the world, some individuals growing to weigh well over 100 kilograms, their ridged, almost dinosaur-like shell giving them an appearance that has earned comparisons to living relics from a much older age. Despite that formidable size and reputation, both snapping turtle species generally prefer retreat and stillness over confrontation whenever possible, reserving their powerful bite mainly for genuine self-defense or, far more often, for the patient, motionless business of catching their own next meal. Further along the same riverbank, a map turtle suns itself on a rock, its shell etched with fine, contour-like lines said to resemble the markings of an old topographic map. Among this species, and several of its close relatives, females typically grow to be significantly larger than males, sometimes several times their weight, an unusually pronounced difference compared to most other turtle species, likely tied to the greater size needed to produce and carry a healthy clutch of eggs. That size difference carries a practical benefit too, allowing males and females of the same map turtle species to specialize in slightly different food sources without competing directly against one another, smaller males feeding on softer insects and smaller prey items, while considerably larger females use their broader jaws to crush open the tougher-shelled mollusks a male's more modest bite simply couldn't manage. And tucked into the leaf litter along the shallow edge of the same river, a small, dark-shelled musk turtle moves slowly through the mud, ready, if disturbed, to release a distinctly unpleasant musky odor from special glands near its shell, a defense that has earned this same modest little turtle its enduring, if somewhat unglamorous, nickname among people who share its waterways, the stink pot. Despite that memorable nickname, the musk turtle remains one of the more genuinely interesting small turtles to observe closely, spending much of its time walking deliberately along the very bottom of shallow, slow-moving water rather than swimming through open water the way many of its relatives prefer, using that same unhurried, bottom-walking style to search patiently for small invertebrates hidden among submerged leaves and debris. Let the water fall behind us now entirely, the sound of the river fading into silence, replaced instead by dry, rustling grass and the low hum of insects in warm evening air. Here, on solid ground, we meet a completely different branch of this same ancient family. Tortoises, unlike every turtle we've followed so far tonight, live their entire lives on land, and their bodies reflect that difference clearly. Where a sea turtle's limbs have become long, flattened paddles, and a river turtle's feet remain lightly webbed for swimming, a tortoise's legs have become sturdy, rounded, almost elephantine columns, built purely for slow, steady walking across dry earth rather than for moving through water at all. Few tortoises anywhere capture the imagination quite like the giant tortoises of the Galapagos Islands. Among the largest tortoises alive today, some individuals weighing well over 400 kilograms and living past a full century in the wild. Different islands across that same small archipelago produced strikingly different shell shapes, some rounded into a high, domed shape, others curving upward at the front into a distinctive saddleback, a shape that allows the tortoise to stretch its long neck higher to reach taller vegetation on islands where low-growing plants are scarce. It was details exactly like these, small variations in shell shape from one island to the next, that helped a young naturalist named Charles Darwin begin quietly questioning everything he thought he understood about how species come to be. What makes those subtle differences in shell shape so significant, scientifically speaking, is how directly they connect to the specific conditions of each individual island. On islands with abundant low vegetation, a rounded, domed shell proved perfectly adequate, offering strong protection without any particular need for extra neck reach. On drier islands where food grew sparser and taller, individuals with a shell curved upward at the front, allowing a slightly longer stretch of the neck, would have had a genuine advantage reaching food their flatter-shelled neighbors could not. Multiply that small advantage across many generations, and an entire distinct shell shape gradually became the norm on that particular island, a living demonstration of exactly the kind of gradual change Darwin would later spend years working to explain. Far across the Indian Ocean, on the isolated coral atoll of Aldabra, an entirely separate lineage of giant tortoise has followed a remarkably similar evolutionary path, growing to comparable size in near total isolation from its Galapagos relatives. One individual from this same population, a tortoise named Jonathan, currently residing on the island of St. Helena, is believed to be roughly 190 years old, making him very likely the oldest land animal alive on Earth today, a single, patient witness to nearly 2 centuries of human history unfolding entirely without his notice. Jonathan hatched sometime in the early 1830s, which means his own long life has quietly overlapped with the invention of the telephone, both world wars, the moon landing, and the entire modern history of powered flight, all of it unfolding around him while he continued his own considerably slower, steadier business of grazing, resting, and simply persisting, one unhurried day at a time. Not every tortoise lives quite so long or grows quite so large, of course. Across the hot, dry deserts of the American Southwest, desert tortoises survive the punishing heat by digging long, cool burrows deep into the earth, sometimes stretching many meters back from the surface. Those same burrows, once dug, rarely serve only the tortoise that built them. Owls, snakes, insects, and a wide range of other small desert creatures regularly shelter inside abandoned or shared tortoise burrows, making the humble desert tortoise something ecologists call an ecosystem engineer, an animal whose ordinary daily habits quietly create shelter and opportunity for dozens of other species living alongside it. A desert tortoise can also survive remarkably long stretches without any fresh water at all, storing what moisture it does find in a specialized bladder capable of holding a substantial reserve, drawn on slowly through the driest months of the year. When rain does finally arrive, often as a rare, brief desert downpour, a tortoise will drink as much as it possibly can in that short window, sometimes visibly swelling with stored water, insurance against however many dry weeks or months might follow before the next rain finally comes. A close relative found across the sandy pine forests of the southeastern United States, the gopher tortoise, plays a nearly identical role, its own burrows estimated to provide shelter for well over 350 other species over time, from burrowing owls to indigo snakes to countless insects, an entire hidden community resting quietly beneath the surface, made possible by the patient digging of one slow, unassuming tortoise. A single gopher tortoise burrow can extend more than 10 meters back into the earth, wide enough for the tortoise itself to turn around comfortably at any point along its length, and cool enough, even during the height of a Florida summer, to offer genuine relief from surface temperatures that would otherwise prove dangerous to many of the smaller animals sheltering there alongside it. Lose the gopher tortoise from a particular patch of forest, conservationists have found, and that entire secondary community of burrow-dependent species tends to disappear along with it, a clear demonstration of just how much ecological weight a single, patient burrowing species can end up carrying. Nearly every tortoise, wherever it happens to live, shares one further trait in common. Almost all of them are strictly herbivorous, grazing slowly on grasses, fallen fruit, and low vegetation, their entire metabolism running at a notably slower pace than most other animals of similar size, a quiet, patient rhythm that may itself be part of the reason so many tortoises manage to live for such an extraordinarily long time. Let's stay here on dry ground a little longer, moving now from open desert into the dappled shade of a quiet woodland floor, thick with fallen leaves and soft, decaying wood. The air here carries an entirely different character than the dry desert we just left behind, cooler, damper, thick with the smell of leaf litter slowly breaking down into soil. Somewhere overhead, a last few birds are settling into their own roosts for the night, and the ground itself seems to hold onto the day's warmth a little longer here, shielded by the canopy above from the open sky that let the desert cool so quickly after sunset. Here, tucked half-hidden beneath a fallen branch, we find a box turtle, and something about the way it responds to our presence sets it apart from almost everything we've met so far tonight. At the very first hint of danger, it draws its head, legs, and tail completely inside its shell, and then, remarkably, seals the entire opening shut, using a hinge running across the lower half of its shell, called the plastron, that folds upward like a lid, closing the whole structure as neatly and completely as a small, sealed box. Very few turtles anywhere possess this particular hinge, and it gives the box turtle a level of protection that even a hungry, persistent predator often simply cannot get past. That same hinge develops gradually as a box turtle grows, present only in a limited, less effective form during its first few vulnerable years of life, and only reaching its full, secure range of motion once the animal has matured considerably. Young box turtles, lacking that complete protection, tend to rely instead on simply staying well hidden beneath leaf litter and fallen branches, saving the fully sealed retreat for later in life, once their shell and hinge have finished developing into the remarkably effective defense adult box turtles carry for the rest of their long lives. A fully grown box turtle, sealed completely inside its own shell, presents a puzzle even a determined raccoon or fox will often simply abandon after a few unsuccessful attempts. No visible gap, no vulnerable limb left exposed, nothing to grip or pry against. It's a remarkably complete solution to an ancient problem, achieved through nothing more elaborate than a single, well-placed hinge of bone. Box turtles carry another quiet, remarkable trait too, one tied closely to a strong, almost stubborn attachment to home. Displaced even several miles from its familiar territory, a box turtle will often spend considerable time and effort trying to find its way back, relying on some combination of memory and environmental cues researchers still don't fully understand. Individuals have been documented living and returning faithfully to the very same small patch of forest for 50 years or more, an entire human lifetime spent within a single, modest, carefully known stretch of woodland. Far across the world, on the island of Madagascar, another remarkable tortoise carries a pattern across its shell almost too beautiful to be practical, a radiating star of pale yellow lines spreading outward from the center of each individual scute. This is the radiated tortoise, and that same striking beauty has, unfortunately, made it a heavily targeted species in the illegal pet trade, pushing an already slow reproducing animal toward increasingly serious risk of extinction in the wild. Conservationists working to protect the radiated tortoise have, in recent years, confiscated tens of thousands of illegally collected individuals and single seizures, a scale of trafficking that speaks both to how deeply desirable that star-patterned shell has become among collectors, and to how urgently coordinated protection is needed if the species is to have any real chance of recovering in the wild rather than surviving only in captivity. Elsewhere in Africa, a considerably stranger-looking tortoise has taken an entirely different approach to defense. The pancake tortoise carries a shell so flattened and unusually flexible that it cannot withdraw into it for protection the way most of its relatives can. Instead, when threatened, it simply wedges its flattened body deep into a narrow crack between rocks, inflating its lungs slightly to jam itself firmly in place, becoming, in that moment, almost impossible for any predator to physically extract. That same flattened shell, so unusual among tortoises, also makes the pancake tortoise a surprisingly fast and agile climber for its kind, capable of scrambling quickly up and over rocky outcrops in a way that a heavier, more traditionally domed tortoise never could manage. It's a clear example of a species trading away the classic, familiar armor most people associate with tortoises in exchange for an entirely different, equally effective survival strategy, better suited to the particular rocky terrain it calls home. Across nearly every one of these remarkable tortoises, one particular quality keeps reappearing, again and again, in study after study. Longevity. Slow metabolism, careful energy use, and a reproductive strategy built around producing relatively few offspring across an extremely long lifespan all seem to work together, allowing many tortoise species to age far more slowly, in a biological sense, than almost any other group of animals scientists have studied closely. Some researchers now believe certain tortoise species show little measurable decline in health or fertility even after a full century of life, a kind of biological patience that continues to genuinely puzzle the scientists working to understand exactly how it's achieved. That puzzle has, in recent years, attracted growing scientific attention well beyond turtle biology alone, as researchers studying aging more broadly look to species like giant tortoises for clues about what genuinely slow, healthy aging might actually look like at a cellular level. Some studies have pointed to unusually effective cellular repair mechanisms, and to genes associated with cancer resistance that appear notably more active in long-lived tortoises than in most other animals, hinting that this same unhurried, patient creature may still have a great deal left to teach us, well beyond anything its quiet, steady presence might suggest at first glance. Let's turn our attention now to something a little less visible: the quiet, hidden machinery running beneath every shell we've encountered so far tonight. It might surprise you to learn that a turtle's shell, far from being a simple, insensitive suit of armor, is actually threaded through with nerve endings, richly supplied with blood vessels, capable of feeling pressure and touch almost the way our own fingertips can. Gently stroke the shell of a turtle accustomed to human contact, and you may notice a small, visible response, a slight shift, a subtle lean into the touch, evidence of just how much sensation actually passes through that seemingly solid surface. That sensitivity makes a certain kind of evolutionary sense once you think it through. A shell built purely as dead, insensate armor would leave its owner unable to detect an early, gentle probe from a predator testing its defenses, or unable to feel a parasite or leech attaching itself to a vulnerable seam between plates. By keeping the shell richly supplied with nerve endings, evolution has quietly turned what looks, from the outside, like a simple protective shield into something considerably more like an extension of the turtle's own skin, alert and responsive across its entire surface. Turtles have no external eyes at all, no visible flap of skin or cartilage the way we do, and yet they are far from deaf. Sound reaches them instead through vibrations carried directly through the bones of the skull and jaw, particularly low-frequency sound, allowing many species to sense the approach of a predator, or the presence of another turtle nearby, through subtle vibrations passing through water or even through solid ground. That reliance on vibration rather than open-air hearing turns out to be particularly well suited to a nesting female's own remarkable behavior. Some researchers now believe hatchlings still inside their eggs may be able to sense the low vibrations of their siblings nearby, contributing to that same synchronized emergence we discussed earlier tonight, an entire nest of hatchlings coordinating their timing not through any sound we could hear ourselves, but through subtle vibration alone, passed quietly from shell to shell in the dark. Their eyesight, in turn, tends to be considerably better than most people assume. Many turtles can perceive color clearly, and evidence suggests several species can see well into the ultraviolet range entirely invisible to us, a capability likely useful for spotting ripe, nutritious fruit against a backdrop of ordinary green leaves, or for recognizing subtle markings on a potential mate that would otherwise go completely unnoticed. For sea turtles in particular, good underwater vision serves an additional purpose beyond feeding and courtship. Recognizing subtle differences in water clarity, current patterns, and even the particular quality of light filtering down from the surface likely all play some small part in the broader sense of place we discussed earlier tonight. One more thread woven into an already remarkable set of tools these animals use to navigate a world with no fixed roads or landmarks to guide them. Communication between individual turtles, too, turns out to be far richer than the silent, solitary reputation most people assign to them. Certain freshwater species have been recorded producing soft clicks, grunts, and low hums during courtship. Among one particularly striking example, the giant South American river turtle, researchers have documented an entire, surprisingly complex vocal relationship between mothers and their hatchlings, calls exchanged both before and immediately after hatching, apparently helping coordinate the precise timing of when an entire nest of young turtles should finally emerge together and make their collective journey down to the water's edge. Recording equipment sensitive enough to capture these calls only became widely available to researchers fairly recently, which means an entire hidden layer of turtle behavior, quiet vocal exchanges passing between mother and offspring, and even between hatchlings still sealed inside their own eggs, went almost completely unnoticed for the majority of the time scientists have spent formally studying these animals. It's a humbling reminder that even a creature as widely recognized and thoroughly documented as the turtle can still hold entire dimensions of its own behavior in reserve, waiting for the right technology and the right patient researcher to finally notice. That same instinct toward carefully coordinated timing echoes something we noticed earlier tonight among sea turtle hatchlings as well, an entire clutch of siblings somehow synchronizing their emergence from a shared underground nest, working together in a way that clearly benefits from more communication passing quietly between them, egg to egg, than most people would ever assume possible from an animal so often imagined as simple, slow, and largely silent. And beneath all of it, the same patient cold tolerance trick we noticed earlier in freshwater turtles reappears in slightly different form. Certain species, when temperatures drop sharply, can slow their entire metabolism down to a small fraction of its normal rate, drawing on stored energy and specialized tissue near the tail to extract what little oxygen they need directly from the surrounding water, resting in an almost suspended state for weeks or months at a time, waiting, with what looks very much like total confidence, for warmer days to eventually return. This whole process, sometimes called brumation to distinguish it from the deeper hibernation of mammals, allows a turtle's body to essentially idle at the lowest possible setting compatible with life, heart rate slowed to a bare handful of beats each minute, all non-essential activity suspended, conserving every available scrap of energy until conditions above the waterline finally improve enough to make active life worthwhile again. It's perhaps the clearest possible illustration of the patience we've circled back to again and again tonight, an entire season spent simply, deliberately, waiting. Let's widen our view for a while now, away from any single turtle, and toward the much larger place turtles have quietly held in human imagination, for about as long as human imagination has existed at all. It's worth pausing here, before we go any further, to notice how unusual that kind of lasting cultural presence really is. Plenty of animals appear briefly in a culture's stories before fading from relevance as circumstances change. Very few manage to hold a consistent, recognizable symbolic place across cultures that never had any contact with one another at all, separated by entire oceans and thousands of years. That the turtle has managed exactly this suggests something about the impression it makes on anyone who spends enough time simply watching it. Across an astonishing range of unrelated cultures, scattered across entirely different continents, a strikingly similar image keeps reappearing. A great turtle, patiently carrying the whole of the world balanced on its back. Versions of this same world turtle story appear in Hindu tradition, in the folklore of numerous indigenous peoples across North America, and in Chinese cosmology, each one arriving independently at the same basic, quietly comforting idea, that the entire world rests, ultimately, on something patient, steady, and unhurried. It isn't difficult to understand why so many different cultures might have landed on the same image without ever comparing notes. A turtle's whole manner, the deliberate walk, the way it can seal itself away from danger and simply wait, the sheer, improbable length of its own life, all of it suggests an animal built around patience and endurance in a way few other creatures so plainly demonstrate. Long before anyone understood genetics or continental drift, people watching turtles move slowly through their own daily lives seem to have arrived at a shared, intuitive respect for exactly the same qualities we've spent this whole evening exploring together. Beyond that shared mythic image, turtles have carried genuinely practical symbolic weight in many cultures too, tied closely to ideas of protection, endurance, and wisdom accumulated slowly over a long life. In parts of East Asia, the turtle appears alongside the crane as a traditional symbol of longevity itself, appearing in art, architecture, and ceremony as a quiet wish for a long, well-protected life. Very few animals anywhere have managed to accumulate quite so consistent a symbolic meaning across quite so many unrelated corners of the world, all pointing back to the same basic, observable truth, that here is a creature built, in every sense, to endure. That same quiet, patient nature carries real ecological weight too, well beyond any myth or story. Out on the seagrass meadows where our first green turtle spends much of her life grazing, her steady feeding habits actually help keep those meadows healthy, trimming the grass in a way that encourages fresh, more nutritious growth, not unlike the effect careful mowing has on a garden lawn. Remove green turtles from an ecosystem entirely, as has happened across parts of their historic range, and seagrass meadows tend to grow overly long and unhealthy, eventually collapsing in ways that ripple outward to affect the fish, invertebrates, and countless other species that depend on those same meadows for shelter and food. Seagrass meadows themselves, quietly maintained in this way, provide an additional benefit that reaches far beyond the turtles and fish living directly within them. Healthy seagrass captures and stores significant amounts of carbon from the surrounding water, functioning as one of the ocean's quieter, less celebrated defenses against a warming climate. In this sense, a single green turtle, grazing patiently across the same meadow night after night for decades, ends up playing a small but genuine part in a much larger, planet-scale system, entirely without any awareness of the role she's actually filling. That deep ecological importance, unfortunately, sits alongside a genuinely difficult modern reality. Many turtle species today face serious, mounting pressure, from accidental capture in fishing gear, from the loss of nesting beaches to coastal development, from the illegal trade in shells and live animals, and from plastic pollution drifting through the very same oceans these animals have navigated successfully for tens of millions of years. In response, dedicated conservationists have developed practical tools like turtle excluder devices, simple metal grates fitted into shrimp trawling nets that allow a captured turtle to escape safely before it can drown, alongside beach protection programs, and carefully managed hatcheries designed to give hatchlings a better chance of surviving that first, most dangerous stretch of their long lives. None of that protective work happens automatically. It depends on volunteers walking nesting beaches through the night during peak season, on fishing communities willing to adopt new, slightly more expensive equipment for the sake of a species they may never directly benefit from themselves, and on decades of patient, unglamorous fieldwork tagging and monitoring populations too slow-growing to show quick, dramatic results. It's exactly the kind of work that mirrors the animal it protects, gradual, careful, and only fully rewarded across a timescale considerably longer than any single career. Rest for a moment with the quiet, patient thread running through all of this. An animal old enough to have shared the world with dinosaurs, respected across cultures that never once spoke to one another, still quietly shaping the health of entire ecosystems today, simply by continuing to do what it has always done, slowly, patiently, one unhurried grazing bite or one careful nest at a time. Let's drift now, gently, into something older still, back toward the very deep well of time from which every turtle we've met tonight ultimately descended. Fossil hunters have, over the years, uncovered a series of remarkable ancestral turtles that help trace exactly how this strange, ribcage-turned-armor design first came to exist. One especially important fossil, discovered in ancient rock roughly 220 million years old, belongs to a creature called Odontocles, meaning, roughly, toothed turtle. It carried a fully formed lower shell, but only a partial upper one, and unlike any turtle alive today, it still had a full set of teeth lining its jaw. That single fossil offered scientists a genuinely rare, direct glimpse of evolution caught midway through its work, a shell still under construction, a mouth not yet fully transformed into the toothless beak every turtle alive today now carries instead. Before that fossil's discovery, researchers had long debated exactly how a turtle shell first evolved at all, whether the bony plates formed from armor plating added onto the skin, similar to an armadillo, or whether they formed instead from the ribs themselves gradually widening and fusing together. Odontocles settled that debate rather conclusively, its ribs already clearly broadened and flattened into shell-like form, confirming that a turtle's protective shell truly did evolve outward from its own skeleton, rather than being added on top of it as a separate layer of armor entirely. Millions of years later, long after that early, transitional design had fully settled into the familiar shape we recognize today, an entirely different kind of sea turtle grew to a size that dwarfs anything swimming through our oceans now. Archelon, a marine turtle that shared its world with the very last dinosaurs, grew to more than 4 meters in length, larger than a small car, its enormous flippers built for powerful, sustained swimming across ancient seas that have long since vanished entirely from the modern map. When the asteroid impact that ended the age of dinosaurs finally arrived, Archelon and its closest relatives were lost along with so much else, leaving today's much smaller sea turtles as the quiet, surviving remnant of a once far larger and stranger family. Fossilized specimens of Archelon, recovered mostly from ancient seabed deposits in what is now the central United States, show a shell considerably softer and more reduced than a modern sea turtle's, likely covered in leathery skin not unlike the leatherback we met earlier tonight, hinting that this particular strategy, trading hard armor for a lighter, more flexible frame better suited to sustained open ocean swimming, may have arisen independently more than once across the deep history of this remarkable family. It's worth pausing here just to notice how much has changed around turtles, again and again, across that entire span of time, while the turtles themselves have changed remarkably little by comparison. Continents have drifted apart and collided anew. Entire mountain ranges have risen and eroded back down to nothing. Ice ages have come and gone, again and again. And through all of it, this same basic, quietly brilliant design, a body built around permanent, load-bearing armor, has continued working, largely unchanged in its fundamentals, right up to the shape gliding through dark water, or resting on a sun-warmed log, or walking slowly across desert sand, in every story we've shared together so far tonight. Turtles today, it's worth remembering, also come with considerably more regional naming confusion than most animals ever accumulate. In parts of the world, the word turtle refers only to sea-dwelling species, tortoise to those living entirely on land, and terrapin to those living in fresh or brackish water, a small but genuinely useful three-way distinction that other regions simply don't bother maintaining at all, using the single word turtle loosely to cover every single one of them, sea, land, and river alike, regardless of where any particular individual actually happens to live. None of that naming inconsistency troubles the animals themselves in the slightest, of course, going about the same patient, unhurried business regardless of which word happens to be used to describe them in whatever corner of the world they happen to call home. It's a small, gentle reminder that so much of how we categorize and label the natural world reflects our own particular linguistic history far more than it reflects any genuine, meaningful boundary within nature itself. There's one more kind of turtle story worth sharing before we let this night finish turning toward morning, not about any single animal this time, but about the patient, careful attention people have spent generations building around these ancient, unhurried creatures. That attention takes many quiet forms, rarely glamorous, almost never quick. A researcher wading into a cold river at dawn to check a string of baited traps, hoping simply to confirm a single map turtle is still present in a stretch of water surveyed the year before. A volunteer walking the same 3 kilometers of beach every night for an entire nesting season, flashlight dimmed with a red filter to avoid disturbing any turtle that might be coming ashore. None of it looks especially dramatic from the outside. All of it, patiently repeated across enough seasons, adds up to nearly everything we now understand about these remarkable animals. Perhaps no single turtle illustrates the cost of losing that patience quite as clearly as one particular Galapagos giant tortoise named Lonesome George, the very last known individual of his particular subspecies from Pinter Island. 4 decades, researchers searched hopefully for any surviving mate, hoping to prevent his entire lineage from disappearing forever. When George finally died in 2012, having lived an estimated 100 years, he became less an individual loss and more a quiet, universally recognized symbol, a reminder of exactly how much can vanish permanently when a slow-reproducing, long-lived species is pushed too far, too quickly, for its own patient nature to recover from in time. George's story carries an unusual kind of weight precisely because so much of his life played out in careful public view, decades spent as one of the most photographed and closely monitored individual animals on the planet, visited by researchers, conservationists, and curious travelers from around the world, all hoping, in their own way, that some solution might still be found in time. That it wasn't, in the end, has made his story one of the most frequently cited examples in modern conservation education, a single, patient tortoise standing in for an entire, much larger lesson about the true cost of delay. That same hard lesson has, in turn, shaped decades of careful, patient conservation work elsewhere. Satellite tracking tags, considerably smaller and lighter than the collars we might picture on a large land mammal, have been fitted onto the shells of sea turtles across the globe, revealing migration routes scientists could once only guess at, tracing individual animals across entire ocean basins, month after month, year after year, slowly building a genuinely detailed picture of journeys that had remained almost entirely invisible until only very recently. That patient data collection has led, in a number of encouraging places, to genuine recovery. Along certain protected nesting beaches, once heavily disturbed by unrestricted egg collection decades ago, careful, sustained protection has allowed green turtle populations to slowly, steadily rebound, entire nesting seasons now returning numbers that would have seemed hopeful even to conservationists working there only a generation earlier. It's slow work, exactly the kind of work a turtle itself might recognize and quietly approve of, small, steady improvements, compounding gradually across years rather than arriving all at once. Some of the clearest examples of that recovery have come from beaches where local communities themselves took on the role of protector, transitioning from harvesting eggs for food or income toward guiding careful, well-managed ecotourism instead, turning a nesting sea turtle into a source of steady, renewable value rather than a one-time meal. Those same communities often report a particular kind of quiet pride in watching hatchling numbers climb year after year, a tangible, visible measure of patience finally paying off, one protected nest at a time. Much of what we've shared together across this entire 2 hours, in fact, the migration routes, the nesting behavior, the surprising vocal communication between mother and hatchling, has only really come into focus over the last few decades, as researchers willing to spend entire careers patiently observing these unhurried animals have slowly assembled a picture that earlier generations could only partially imagine. It's a fitting kind of tribute, in its own way, that understanding a creature built so completely around patience has required exactly that same quality from the people trying to understand it. Every one of the species we've walked through together tonight, from the deepest diving leatherback to the smallest, most brightly patterned musk turtle, still has a great deal left to reveal to anyone willing to keep watching closely enough, for long enough. That, in the end, may be the most fitting compliment we can offer an animal that has spent 200 million years quietly demonstrating the value of simply taking one's time. And now, very gently, let's return to where we began. That same warm, dark sea. That same slow, steady swell rolling beneath a sky that has, by now, begun to soften faintly at its eastern edge. Our green turtle, having spent the whole of this long night gliding easily through open water, is rising now, unhurried, toward the surface, breaking through into the cool morning air for one long, easy breath before sinking gently back beneath the waves once more. There is something quietly moving about picturing that single, unhurried breath, taken at the very end of a long night spent almost entirely below the surface, patient and unhurried in exactly the same way everything else about her has been tonight. She does not linger at the surface any longer than she needs to. There is no urgency in the moment, only the simple, practical business of drawing in enough air to continue, before returning once more to the quiet world she has always called home. Somewhere behind her, along that same quiet stretch of shoreline, a handful of hatchlings from the very beginning of our story have, by now, reached the safety of a drifting raft of sargassum weed, resting there together after their long, exhausting swim, finally still for the first time since they broke free of their sandy nest so many hours ago. Somewhere far out over open water, a leatherback continues its own deep, patient dive, entirely unaware of how many jellyfish it will need to find before this particular day is done. Somewhere on a quiet reef, a hawksbill noses gently into a crevice between coral heads. Somewhere in a slow, winding river, a painted turtle shifts slightly in the mud, still weeks away from the thaw that will finally return her fully to the world above. We've traveled a considerable distance together tonight. Across open ocean and quiet river, onto dry desert ground and damp forest floor, back through millions of years of deep time, and finally here, to this same soft stretch of water where we first began. We've met turtles built for speed through open water, and tortoises built for a slow, unhurried walk across solid ground. We've watched a whole clutch of hatchlings emerge together into their very first night, and followed one patient, ancient traveler through the better part of an entire evening at sea. Consider, for a moment, everything that single stretch of shoreline behind us now quietly contains. Buried nests still weeks from hatching. A scattering of fresh tracks left by mothers who came ashore earlier this same night and have already returned to the water. Small, sun-bleached fragments of much older shells, worn smooth by years of tide and sand. An entire long, patient history, folded quietly into one ordinary strip of coastline that most people passing by would likely never think twice about. And through all of it, every single one of these remarkable animals has done exactly what turtles have always done, for longer than almost any other creature alive today. Moved slowly, protected what mattered most, endured one patient season at a time, long after so much else around them has changed completely. The sky continues to lighten now, gently, the way it always eventually does. There's nothing more you need to do tonight. No further distance left to travel. Just rest here a while longer, in this same slow, patient quiet that has carried us the whole way through, and let the morning arrive in its own unhurried time. Thank you for spending this time here, in the quiet, steady company of these remarkable animals. Join us next week for another quiet adventure. May the same unhurried patience we've spent 2 hours describing settle gently now into your own rest.